infinite fault, right? How come? Right? No one asked me these questions. I press Control C, all naughty fault program are just gone. Right? It seems to be impossible. Why? Because to you, Control C means that I kill the process. I didn't say which process to kill, right? I just say kill the process. So the foreground process should be killed, right? Now today I will also talk about the reality of what is a terminal control signal. Okay, so the Control C, Control Z, even the Control / they are all terminal control. And terminal control signal has certain special property. Now here is where we stopped last time. Where we stopped last time, we talked about hardware signal. Whenever a hardware signal comes in, you will interrupt CPU execution of your original code. And today we talk about user-defined handler on default signals. What are the default signals? Let's say Control C is a default type of signal. You cannot remove it, right? It is always in the system. Now you can choose it to be handled in your own way when it's fired, when it gets triggered. Okay? So this is the POSIX signal. And I just talked about the terminal control. So the terminal is actually the thing that you launch in your Mac, in your Windows. Okay, Windows, I don't know how you open terminals for Mac. I just iTerm. So I open a terminal, and when terminals launch, you can type Control C, Control Z, Control / I don't know how many of you know what is Control /. If you don't know, very easy. Launch your shell program, and without a signal handling, click it, then your process will be killed. Okay, so it's one of the termination signal. Control C, definitely you know, is also kill the process. This is suspension. I don't know whether you have tried the suspension. All right, so the suspension is actually in item. I have updated the entire example code. Okay, please go there and have a git pull. Okay, I already did so I can Control C it. Then all the chapters are already updated. So I have a very, very hardworking week. All right, so I have a program called infinite loop. So basically, it's a looping. For every second, I tell you that, hey, this is the second 1, second 2, second 3, so on and so forth. I type Control Z. You will see there is a stop there. If you're already looking into the specification, as well as you try to move on to the phase 2, you will find this signal extremely important because it means that it will suspend your foreground process. And the signal later I will tell you, we call it terminal stop. Okay, terminal stop signal. Okay, another signal is called stop signal. It's another thing. So when you suspend it, you can type foreground to bring it back to life, just like our specification. Now, what is it? What are they? Very important thing now. Second of all, this is one source of a signal. Another source of signal is by some program. Of course, those program is actually a calling system call. So I can skip them and go to here. So the system call to send signal is actually called Q. Okay? Don't get it wrong. Q means send signal. Send a signal. So the Q program, then we have the Q program, we have the Q system call. Both are for sending signal. You remember last time I tried this with you? I have the infinite loop here. It is running. Okay? So this is running. This is the PID. Okay, I copy, open a new terminal. All right. So remember last time I demonstrated to you. Now this is should be running. Oh, sorry, should be running, and I send a signal to that process. Okay. Last time the signal that I sent is this guy, segmentation fault signal. Okay. Then when the process in the shell here receive this signal, it will die and say there's segmentation fault. Okay? So remember, Q is not to kill someone, but to send a signal there. All right. So this is a system call. Now that means that when you know what are the parameters to put in, you will be able to control other processes. Yeah. The previous case that I just used is this program, right? The infinite loop. Okay. So basically, how can we decode what are the actions behind it? Now remember, it's very important. Don't say Control-C, kill your process. Okay. We said, okay, let's say the Q program, the default signal of the Q program is to generate a signal called sig term. Okay, so what is sig term later on I will show you. And this sig term is actually a signal with certain default behavior. And the default behavior, so we call it not default behavior, we call it default signal handler is termination. Okay? So these two combined together give you an illusion that you are being killed. So why I say it's so strangely? Because this default signal handler can be changed. You can send the same signal to that process, but that process can handle it in another way. Okay? So sending a signal, the consequence may not be killing. Previously, I also tried in front of you guys, I tried to handle segmentation fault signal. You send me segmentation fault signal, I behave differently and say that no, there's no segmentation fault, okay? I said goodbye or press Enter key to continue, okay? Yeah, you can do so. All right? So this is something that really some basic things, but very important and fundamentals. Okay? Now, what are the possible signals that you can play with? Now this table, it seems to be ugly. Okay, I consider it's ugly. I give you something even more ugly. Okay, so where can you find it? Now, first of all, you don't need to rely on my lecture notes. You can rely on here. Man7 signal. Okay, so yeah, you can find so many hints from Google. Man7 signal means go to chapter 7 of signal, and signal chapter 7 is the list of all signals that Linux have. So what are they? Many. A bunch of things. See? Well, number one is sig half, sig in, sig q, sig quit. Sig illegal is very interesting. During another course talking about security, then you will face this. Security course will have illegal instructions, sig segmentation fault, whatever thing, then you will find it, oh, it's not sig kill, but kill me, okay? Yeah. Here is the value. Here is just a defined name. So this is the definition. There is someone use a number sign define. Define sig in is 2. Or 2 is sig in. And what is the default signal handling routine? Is here. Three type. One is termination. Kill it. Just kill it. Second is, let me find it up. Ignore it's not one. Where is the sig terminal stop? Oh, here, stop. Okay, so we stop the process. So there are more than one kind of stop. Sig stop, sig TSTP, and the last one is core. So core is, now you seldom find it. Okay, what is core? Core is, we call it core dump. You can terminate a process and leave a file called core dump. That core dump is, before it dies, it's dump its entire memory into a file. And you can use debugger, GNU debugger, GDB, to load that core as well as your program. Then you can immediately just like bring the program back to life. And if we animate what happens, okay? So this is a core dump. We seldom talk about this core dump. If I have time, let me find some resource for you guys. Okay. So others ignore continuation. This is only kind of continuation. Okay. So this is a whole bunch of things, and this is not the end. See? Wow. What is that? Oh, profiling. Okay. Yeah. So many things here. So I won't cover them all. Okay. If I cover them all, it becomes a course. All right. So these are the most common thing that you will see. What are they? Control-C, the default the Q program default signal. You send Q, type Q, or you can try this. Let's say I'm running this program. This command exists in both Linux and Mac machines. Kill all. Okay. What is the difference between kill and kill all? Kill require you to type PID. Okay. Kill all will kill all process using that program name. Okay. So I kill all infinite loop. So it can kill all process carrying that program name. Okay, so this is very convenient. Kill require you to type PID, but seldom look up PID for you guys, right? Except that when I run it, I print it out like this. Okay, so this is kill all, but the default signal number is 15. So what is 15? Look up here. Can you find 15? Here, termination. So this is the default one. And what else? Terminal stop, continuation. This is the pair. You tap Control Z. This is the signal. We'll type foreground. The shell fire signal, continuation signal to the process so that the process continues to run. Okay, so this is to a pair. This you already know it. When you the process is being terminated. It will send a sick child to his parent. And the sick child that you set on fire. Here is the new kill weapon, sick kill. No process can stand against it. Okay? You send the signal, kill. Usually we'll type like this. Kill -9, and then that PID. Then that guy must die. Or you don't remember it's 9, kill minus kill. The same. Okay? So this new kill weapon, how powerful it is, you can read the kernel code. Okay, ED class already know how to read kernel code. The kernel code has some hard code if anything else there. Say that if the signal is sick kill, then boom, kill it. Okay, no matter what. Okay, so this is a must die signal. So that's why no one can handle this must die signal. Okay, you cannot change, this is the only knife that the kernel has. You cannot modify it. Okay? So, now what is going on here? I will tell you something about the assignment 1. Okay? So, this is a combination of a set of signals. Let's skip to the end result. So, the end result will be something like this in the assignment. Okay? So, in the assignment, how you will play with, in phase 2, play with the signal. All right. The parent and a child, let's think of the case. The parent is a shell. The child is some infinite loop. Okay? You create infinite loop program, and then compile it, you run it on your shell. So you will use fork and execute, right? You fork the call fork, create a new child, and a child called ESCC. Any one of the ESCC family become the infinite loop. And while it's running, we call that process in the foreground. Okay, in the foreground. Then you type one thing, Control Z. You type Control Z. So you will see something like this, Control Z. And this is TSTP. Now here, what is this? What is this? Before this, we will have the wait PID return. Our children, I didn't read the tutorial notes. I don't know whether they talk about the wait PID special thing, okay? It knows one thing, whether you're returned back to life or being killed. So let's do this. I have this guy running, copy the PID. All right, so I do a Control Z. As if this is your shell. Now, I'm doing the following. And you tell me what's wrong. Or is it normal? Okay? So this is the command. So what is it? It is continuation signal firing at that stop process. Now you tell me whether it is normal. I just sent a continuation signal, okay? to think about the status of the shell. What happens if I type ls and enter? Guess. It run ls or not run ls? Interesting question. Yeah, it's running the infinite loop, right? But I said I want to type ls and enter. We think that it will not run the ls. No. How about run the ls? Some other segmentation box. Right. Who's segmentation for me? Okay. Let's go. ls. L8, okay. Enter. We have ls. We have ls. So let's reset the entire story. I will use Q. Not continuation now. Kill it. Yeah, it dies. Okay, it dies. It says, oh, being killed. Okay, again. We do it again. So this is the foreground process running. All right. And imagine in your phase 1 implementation, it is in the foreground. What happened to the parent process? Parent process is in wait or wait PID. I don't know which, but it's waiting. So when you type ls enter, nothing happened, right? Nothing happened. As if this ls enter goes to, the standard input stream, goes to the foreground process, but the foreground process didn't call getS, it didn't call scanf, so it just ignored it. All right? So I just do another thing. Q terminal stop, suspend it. Oops, wrong PID. Yeah, this is OPID, sorry. This is new PID, fire. Okay? Yeah, interesting, huh? It suddenly boom, pop up the ls enter results. Yeah, but ignore it, okay? So I successfully suspended, but so happened that the ls enter already on the input stream, but no one take care of it before it. So when the shells come back, the shell will take it. Okay, so this is a bad illustration, but the foreground process usually ignore it. Okay, unless the foreground process take in using getS, scanf, whatever things. But the idea is foreground process don't let the shell to do anything, and the previous demonstration is problematic. The problematic things start with here. Continuation signal. I send a continuation signal to the process. And now the process becomes a very special status. What is the status? Is it the foreground process? It seems not. I run ls enter. I can send that string to the shell. So it is not a foreground. And does it behave like a background process? Let's check. How can you check it? How can you guarantee that it's running in the background? Yeah, you can use top, you can use PS to check, right? Let's check. PS, AUX, okay, a bunch of things pops up, you don't know what happened. So then I will just grab to search for the report. The report should have my program name called infinite loop. So I can grab the PS AUX report and boom, find this. So it is there, it is in the system. Now I do one interesting thing. Let's vote. What if I close this shell? Close it. Okay? What is the status of that process? Interesting, huh? Let's grab. Gone. Gone. Maybe you don't understand why I try to play with. I do it again. This time is something like this. Oh, sorry. Wrong directory. Examples. Part 3. Again. Infinite loop. All right. So I just let it run. And again, I will put it in the suspension. Oh, this time suspension, I do it here. Suspension. Now, I don't let it run by sending continuation signal like this. I don't do it. I don't do it. I type a command called background. Okay, so this is a shell command called background. It means send any, not any. In the most recent process, or I shouldn't say most recent, is based on the job list here. The job list, I have one guy, so I choose to put this guy into a background. Now, background, go. It's running, right? It's running. As if the same case that I use another terminal, send continuation signal to this process. So it keeps running, and the behavior just the same. ls have something shown, no problem. So as if it's running in the background. Now, I use this command again. Oh, sorry. Find it out. It is still running. Very good. Close this terminal. It's gone. It's gone. Okay? Any problem? Or I should say that, do you find anything not normal? If you don't understand, don't worry. Keep this in mind. We will revisit it in next part. Okay? We will revisit it in next part. Okay? Yeah, this is something that because nowadays you guys don't use Linux, don't use Unix, always use Windows. Okay? And you never seen this before. Okay? Back in my time, I already tried thousands of times in using terminal and sending something in the background, maybe more than a dozen. So this will be something that I always try. Okay? For you, please go home and try my experiment again and again to see different things pop up or different results pop up. And then we will talk about this scenario, this case. What happened in a system when I close the terminal but with something in the background? Okay? We will revisit it in next part. Now, we go back to this case. Okay? So this case, you know that this is a background job. I send something in the background. And when it's running in the background, I don't say that it is a definition of a background, but you will find that the parent process will keep running. I don't keep dot here. Dot here means that I'm being in suspension mode. I consider this even though you are calling scanf, fget, get line, whatever called for reading the sender input, I consider this is a solid line, not suspended. Okay? So in this moment, you have two processes running in parallel. Okay? As if it's running in parallel. And this is what we call not a definition, but very close. We call it a background job. Okay? And this is a combination of these two guys. Now in your assignment 1, you are not going to implement this. Right? You are required to implement this. You don't need to implement background. In assignment 1, you are asked to create a process, and suddenly some naughty guy saying terminal stop signal is being stopped, and when it stops, you have the parent running again with someone sleep in the background, sleeping, not running. And then you will be allowed to type the command FG, foreground. What is the foreground? Means that bring this guy back to life. Then what should you do? If I just send signal to this location, this previous case, this is not what we want, right? We want is something like this. When I type foreground, you send a continuation signal, yet the shell will be waiting for a termination or another suspension of this green guy. How to implement it? Get any idea? Huh? It should be easy, right? This foreground is to read something from an input, right? But you have to implement it in this behavior. This is for assignment 1. All right? So I hope that you know that there is a continuation signal, right? Continuation signal will happen here. Yes, how to put it in the sleep, and then capable of wait for another termination or suspension signal is your job. Okay? Good. So how to send a signal in a program? Let's play around with this program. Very easy. You can read the main page. Here is a PID, your target. You can send a signal to the target with the signal definition, SIG-INT, or even send a SIG-child, no problem. Okay? You can choose whatever signal you want to send. And the target, you can send to any target. All right? You can send to any target, but unless you are the root, okay? If you are the root, you can send this PID, send PID to anyone. But if you are not the root, this PID, the corresponding process must belong to you. Okay, think about it. If it's not the case, it's funny, right? I can suddenly go to the Mac machines, exit there, and kill all the process. Okay, force someone to lock down. Okay, yeah, this is not the case, right? So this PID, although I say that you can set any values, but this queue system call may not obey and give you error condition or error return value -1. Okay, so this is the call. Now, if you know this is the call, what is this program? I give it 1 minute. 12 lines, yeah? Should be okay for you guys. What this program is doing. Yeah, it's already available in GitHub, so if you are impatient, you can run it immediately. Don't worry, okay? There's no big problem. You can run it as root. I will kill other process. Yeah. Don't think that that's right. Oh, suddenly the program we put the computer. No, it won't. What is that? Oh, by the way, what is SIG term? If you don't know what is SIG term, flip to our previous pages. You will find SIG term. Oh, yeah, I hear you. Yeah, you're right. What is that? Any idea? What is it? First of all, any people who get killed? Or no? Yeah, just this program sucks. It's just don't say anything. Will you say anything else? Can I get it? Well, yes. So what's the target? Himself. Okay, so it's a suicidal action, so that's why it's called suicide.c. Okay, so it will kill himself with the termination signal. It will kill himself with certain probability. I mean, eventually it will die. Okay, but every time it will do some random. Okay, so I just play around and just like for a die. Okay, with 6 phases, right? If consecutively as all 3 times get 6, okay, then I'll kill myself. All right. So this is a simple illustration. But there is a shorthand when you want to kill yourself. Yeah, interesting. I mean, I don't know who invented that library call. Who will want to kill himself, right? But there is a way to kill himself. The call is called race. Okay? Send a signal to the current process. Okay? And of course, you can choose whatever signal. Okay? You can send suspension signal to yourself, queue, segmentation fault, whatever you want. All right? So it's called race. So if you want to kill yourself, you can do this or call race. All right? Now you know how to send a signal. Then how to handle a signal. There are 2 standards. This signal, I already know this is an old standard because this is the time that I learned operating system and I use it. Okay. Nowadays there is another call called. First of all, let you know what is this signal. Okay. So this is the standard C library. Okay, and it's very old, designed for Unix. Okay, And nowadays, in the POSIX up-to-date standard, is recommend you to use 6 action. Okay, so but our assignment is all right. You can use a 6 action or signal. Now let's go back to signal. You can choose the signal name. You can put sig in, sig Q and sig stop cannot be handled. Okay, sig Q, no, but sig in, sig termination, sig quit. And then, what is this? This is a function pointer type. And the function pointer type requires you to put down a function, the name of the function, and its return value should be a void. Return value should be a void, and carry 1 argument integer. So what is that? All right. Yeah, I closed the terminal. Okay, so let's try handle index.c. Wow, too big. All right. So this handle index.c, basically I not just handle the in signal. I don't call it in signal, but interrupt signal. I call interrupt from the keyboard. So this interrupt signal and quit signal, I handle both. When I write that handler function, okay, I can create any name, but the return value must be void. The return value must be void and take 1 input. And actually that parameter means the signal that you just handle. So let's say if I type Control-C, it will put down SIGINT in this value, so that you can check which signal you get a trigger. Okay? And this program originally doing what? Originally is having a get char waiting for your input. And then if I press enter, then it will get past this get char and then end the program. All right? So this is as simple as that. Now I don't want it to be so simple. I will handle the signal, run it. So it's waiting for me. So one of the 2 signals that I will handle, Control-C and Control/. Let's try Control-C. It says I receive Control-C. If I type Control/, it says I receive Control/. Of course, I write it down here. I write them down. Just these 2 messages, Control-C, Control/. So it's basically, you can create a handler that handle many signals and add and create if then else or switch software. It's just up to you. In order to set a filter, hey, what is the signal just come in? Okay, what should I do next time? Okay. Now, this program, what is the status? Take a look at my handler. The handler is here. The handler have if then else and then terminate. It's gone, okay? So you just invoke it and then you leave. Now look at my program. My program seems to be in a very strange state. Yeah. Currently I am in get char, and then suddenly I'm forced to go to the handler. And when handler returns, where should it go? Let's see it. I type A and then enter. You see end of program bracket A. So what is the end of program bracket A? Take a look at the code. It is the character that I just read, and I put down the character I read inside this message. So what is the meaning? The meaning means that you interrupt get char, right? You interrupt get char, and when get char find that, oh, there is some handler, so it will terminate the process. So go to the handler, and when you finish executing the handler, you go back, I will still be there waiting for the keyboard input. Okay? So that when the keyboard input finally comes, it print out. So the interruption means, it seems to be a very peaceful, right? You are not going to stop the get char. You are not going to quit the program, whatever. All right. So, any question you want to ask? Any questions? No? Yeah, this is very important, huh? This program very important. The get chart is being interrupted, yet after the interruption, it will come back. We have a name for it. The name, I will show it later. And I give you another example to contrast with the previous case. The previous case is get chart will still be there serving you after the handling. Now here is another thing. What is this? So I think you wish to do it. Yeah, sleep for 24 hours. Yeah, I want it. Okay, I didn't sleep well these days. Okay, I just sleep for 4 hours today. Really today, yeah, you know when I was get sleep. Huh? And well, this is the handler. I handle control C only. Now let's see what happened. So this is called, what is that? It's gone. What is the name? I can't remember. Ah, break sleep. Sorry, I remember it's interrupt sleep. Break sleep. All right. So I would say I was sleeping for 24 hours, and with something else I include here, I want to check the return value of the sleep. Okay, usually sleep is return value, right? Yeah, this is the first time you see that, oh, sleep is return value. Later on I will explain to you why. Okay? Let's go. Okay? So it starts sleeping for 24 hours. So I won't ask you to come back to that tomorrow and see the result. Okay? I will do Control C now. Where is the sleep? Unlikely, really unlikely, right? We just know that get chart. You interrupt get chart, you can go back to get chart still serving you without any problem. Here is, I say that you will handle it, no problem. You will go to the signal receive message, who print it, I print it. Okay? I print it here. I said signal received. No problem. Now how about the terminal? The terminal receive Control C, and then it says signal received. Then suddenly you see this line. What is this line? This line is actually coming from P error. Okay? So I don't know whether you know what is P error. P error is a very powerful thing. If you get a system call fail, what kind of system call fail? Read, write, or maybe a fault is failed, just failed. I don't know why it's failed. You can use P error. The P error is automatically look up the error number automatically and print out the correct statement to describe what happened. Okay? So previously you see sleep colon interrupt system call. Interrupt system call is being generated by this P error. The sleep is this guy. Okay? So if you don't believe in me, I can change it into another name. Hi. Yeah, sorry, automatic. Okay. Run again. Control C. So this is what I created. Okay, so this is the message that I created, and it gives me the interrupt system call. And what is the problem? The problem is if the system call finished without any problem, it is funny. It will say OK. Yeah, you can try. You can try after printf put P error. Then it will say OK. So if it's not OK, that means some bad things happen. Sleep is very special. How special it is? Yeah, I know time's up, but wait for one more minute. Very special. We have two categories of system call actually. One category allows you to do the restart. Okay? So the get chart in the background is calling read, right? And if you're doing printf, the background is doing write. The read and write call is restartable, or we call it reentrant. It's allow reentrance. And here is something that not allow reentrance. This is not the only call. We have a big table for it. Okay, but I mentioned those important things. What are the important things? Read, write, read, wait, PID also. So what is the result? If you're waiting for a process termination, or waiting for I don't know what are the things, but you handle a signal, you want to handle a signal, then does it mean that I have to call wait PID again? No, it will restart. It will restart. But here, like sleep, you handle the control C, the sleep will break. So you have to call sleep again in order to continue to sleep. All right? So sleep is not restartable. Also, the later system called, I would describe it in this set of slides called pause. Pause is very, very interesting. Okay? These are two categories. Very important. Okay? But I would say this is extra. I don't test your examination. Hey, memorize this table and write it down in an examination paper. It's useless. Yeah. Okay? So this is about a system call, about whether it is restartable or not restartable. Okay? In tonight, we will continue to talk about something more about signal. Signal is very important. One more important thing is, let's say you try to count how many signals received. Does it work? It's not working. You cannot say, okay, I have a loop for 10 times, send to your parent process, let's say, or you even send to yourself. 10 times same signal. Can I count those different signals? Okay. You can go back to the lab and make a short trial over this program. This program already available in the GitHub. Okay.